Hey, welcome to Building Site. We're going to carry on with our GraphQL implementation. I'm going to try and live code a GraphQL implementation, a pretty basic one, from pretty much from scratch, I guess, although we're going to use a few libraries along the way. Don't know how long it will take, maybe 2 or 3 hours. This might be a longer episode. But anyway, let's crack on and get going. So I'm going to start with my usual editor. I'm going to start Emacs, and I've got an open source project called Grab, and we're going to be working on this. So Grab is our GraphQL enclosure. It doesn't really do very much at the moment, and we're going to change that. So quick look at these deps. I'm going to use, I'm not going to use Reap for this exercise. Reap is a kind of ability to a library to parse text, and it's optimized for old internet strings which are encoded in A, B and F, but lots of other kind of oddities that crept in over many years. GraphQL actually has a very modern grammar. Let's have a look at see what we're going to be doing this June 2018 spec, and yeah, here we are. We have a grammar summary. Here's the grammar, and that grammar is, if we look for ANTLR, there we go, we have that grammar here, so we'll take that, and I've copied this to my test area here, so we'll just pop that into the source area. So here it is. And we're going to use ANTLR, which is it's a compiler generator. So let's go to the website. ANTLR, written by Terence Parr. It's been around for donkey's years. If you ever went to did computer science at university or anything like that, you may well have done a compiler design course, and where you have to learn about taking a grammar such like this and using this to generate some source code, which is typically in a language which you compile, and then you can feed it an input document. It's good for writing DSLs. We don't get to use it a lot in Clojure, because in Clojure we have a wonderful system of being able to have code as data, and it's just a data structure, and Clojure is really good at processing data structures. So what we want to do is take a GraphQL document and turn it into a Clojure data structure ASAP. And to do that, look at, there is a library called CLJ ANTLR by Carl Kingsbury, who's behind the sort of Jepson testing plane. So yeah, here we are. There's got a ton of, and the reason we're doing it this way is because it's just more likely when we want to maintain the GraphQL language, just make sure it's up to date. Yeah, so yeah, this is what we want to see, and we also kind of could try this out as a test. So yeah, that's ANTLR. It's just likely to be more maintainable because ANTLR is used for lots of GraphQL implementations. It's more likely that this is going to be maintained, and we don't have to do the work in maintaining it. So that's why we're going to use this. Let's go pop back to Emacs, and first job is to parse this. So we'll write, got a little test here called ANTLR. So what I'm just jack in, going to use that library here that brings in ANTLR. We've got the resource, just make sure that that's there. There you go, that's it. And then we can call GraphQL. Now we can call this anything we like. We call that kind of GraphQL parser, and then that will then turn. I've got a schema 3 here, which is just a test schema, just to test the water. And this is the thing. Well, parsing isn't all that we have to do. So what we're going to try to do is turn this into a data structure. Now I've already done some of the evaluation work So we're going to turn this into something like, or let me, why do we get the schema 3? Let me find, so when I was doing it with Reap, we were turning it into something like this. In fact, we got all these kind of Reap keys and grab keys, so I in the end created a way of dissociating the Reap keys. So this is what we want to end up with ideally when we create when we parse. So we're going to start with so okay, let's put that I'll call that I'm going to start with this, and we're going to end up with this. So we need a function to turn the thing on the left to the thing on the right. So we can visually inspect it. Let's bring up the schema as well. So we've got to start somewhere. There are 4 definitions here. 1, there's the schema, there's the root, there's the type, and there, so ANTLR's done its job. We're going to want to fish out the types and create some kind of structure here. All right, let's do that. So let's write some code. Create our parser. And again, we're going to do it at the REPL. This is kind of what Clojure excels at. It's REPL-driven development. So I'm going to start off with an input document. Here, let's create the parser. We'll create the document. And let's start off by pulling out all of the types in this document. So let's start by pulling out, finding our type root, and this is going to be a kind of object. So let's try and target that one. That would be our second definition. Actually, let's try person. That feels like it would be an easier thing to target. So this is what we want to create. And so let's do it. Okay, so document, and the way I like working is code on the left, results on the right. So document, let's get all of the definitions. So I'm going to map over definition. Let's get the, now this is a list. So we need some way of perhaps, because ANTLR perhaps is returning us a lazy set of definitions, and these are lists. Now we could convert them all to documents, but we need some kind of way to manage. We're going to parse a lot of these, and a lot of these forms are going to start with something. So okay, let us create some kind of maybe a multi-method. Let's try with def multi. Let's have something that will take a list. So process, and it's a multi-method, so it will take a collection and it will dispatch on the first of that collection. Okay, and okay, we can call that just process first, and then we can have a method that says document, and we can destructure this, and I guess this will be a number of definitions. We'll call those definitions, and then for now I just count the definitions. Okay, multi-method, and then we will say process the document, and that returns 4. And the reason it returns 4 is because we're calling this multi-method. This takes the first of the list, we have a keyword, and then subsequent in the collection, and then that would dispatch to this method, and that will return us something. Now what we'd probably want to do is recursively map over those, so let's map process over the definitions, and that might give us, if we say the default is, or I'll just say default, so by default I'll just give something that will say we'll call that unknown. So what I'm expecting now, oops, is when we process, we should get 4 unknowns. No, perhaps need to, that's true. Have I put the default option in the right place? Perhaps not. There we are. Okay, well, we used default. I thought there was a way of changing the, I might put the options in the wrong place. Not sure. Okay. Okay, now we've got 4 unknowns. Okay. Okay, so what we're going to do is process a definition now. So we're going to process a definition will, if we bring up the type system definition, we're going to get, I guess, one of those 3. So I think we can call process and dispatch on, sorry, we'll create a method now for that definition, and that can call process on that will on the first argument, or on the second, so we can call that the inner, I guess, and we can process inner. So now we should get unknown, unknown. If we just destructure now. There we are, these are the, I'll put it a little kind of unknown, not handled. Make that a little map. Okay, now we're not handling the type system definition. So this may well get boring quite quickly. Let me just put so we need to handle type system definition. And type system definition is going to be one of these three. Which we can say process inner. And now we should see, now what we want really is the type definition, because that's the one that contains person. So let's handle that one. So this way of coding is just doing enough we're only making one happy path through the problem. We're taking an example, and we're only doing just enough to handle that example. So our example, to remind us again, is this. Just want to parse this for now. Just want to do enough so I can get my tests that I have already written working, and then we can begin to build more of the GraphQL implementation. But this is pretty much how we would do things from scratch, and I haven't used ANTLR in a few years, and so this is fairly new to me too. But hey, we're just coding live, and we'll see what happens. So now we have type system definition, and we'll see, we'll change that to type definition, process that. Come on. Object type definition, that's the one that we want. Now that, well, let's just print that out. That would be interesting to see. It just says type because we want the whole thing. Actually, we don't want the whole thing. We just want the so that's what we're getting. We're getting a list which will have type. Now, what we could want to ignore the first one. We could just turn it straight into a map, and the way that we could do that is with a zip map, which a zip map takes keys and values. So if we just have values, we could just now zip map it. If we're confident that we're going to get the same in the same order, which I'm not confident. We don't have, do we have an implements definition? We have just a fields definition, because many of these things are optional, including the description. So we can't guarantee that these values are going to be in the same place each time. Okay, that's not great, but let's soldier on. Okay. How do we know that this is not a description? I guess we could have a look. I guess if it was a description, it wouldn't be a string. Let's just put a description in there and see what we get. We can put description before type, it looks like. And I think descriptions are strings. Okay, so we can say people are important. Okay. What do we get there? We get, that's our, here we are, we have a description. Okay, that's good, because then we can distinguish between so I'm tempted to this is an object type definition. We know now that this is a kind of object. At this point we know it's a kind of object. That's great. We know, I'm thinking that we could map process over inner again. But only where only the list ones, and we'll merge all of No, into doesn't take multiple arguments. No, so I can't do that. Yeah. We'll merge them all. So to explain my thinking here, we're going to start off with an empty map when we see one of these things with, we found an object. But we want to also get each of these bits of information into that map. So the kind of thinking I have here is that we will just call process over each one where it is a list, and we will merge all the results. Just show you what that looks like without the into. So let's show you what it looks like without the merge. So we're going to get, oh, nothing. Maybe they're not lists. What is? Oh, find out what type those things are. They are cons cells. Okay. Are they sequential? No, because the first one is the word type. So where they are sequential, we can filter them. So that's what. So this is a kind of information that I'm interested in and want to merge, ideally. So fields definition. So let's process each one of those, and we get name description, not handled. So let's handle name. And if we click on name here, yeah, it should just be process. Should be a case of just returning inner. There we are, root. That is the name of the thing. We're interested in this one actually. So let's call that juxt grab alpha let's just call it juxt grab alpha. Well, yeah, the problem I have here is that I really don't want to have to distinguish whether this is part of a schema, this name is part of a schema or part of a document, and really there isn't any difference, and my old implementation has distinguished those two, so I think we would just use this namespace for now, and then we'll fix up the other tests as we go. So this is going to have a name of inner, so that's what that will do. So this is name root. If we merge all of those maps, well, if we change and we filter, or rather remove, if we then remove anything where there's a there we are. In fact, those are equivalent. I feel this is where we want to do our refactoring. So, and then we want to merge those together. Great. So if we bring our map in, which was the there we are, we're getting closer to our target. It would be nice to bring in the description as well to that third one. If we drop 2 and take 1, we'll see that we can zoom in on the one that we're working on, this person. Okay, so we've got a description to come, so when we process the description, what does that look like? That should just be, let's just show, tell you what, we will just not worry about namespaces for now. Okay, so I think we can say get string value, and that will give us, oh, process inner def method process string value, and we'll make that value. Return that val. There we are, description. Let's remove the namespace on that one, and there we are, getting closer. So we've done it, kind, name, now we need these field definitions, so let's put these field definitions in. Field definitions, I really want to see when I'm coding, I want to be able to see what I'm doing. This is just saying not handled. Okay. See the effect of this. We'll get and not handled, and then we'll get, this is painful, that's only going to show us one of the not handled, but that'll be enough, I think. We can just work on, so fields definition needs to be handled, so we'll work on and that requires the fields definition. That will give us fields, or rather we'll call that terms. And then we want to say, right, that is a field definitions object. We want one of those. And we will process each of the terms for now to see what happens. What happened there? Okay, we're not handling these individual field definitions. Okay. Now, so I'm going to put this in a let because I want to return these field definitions indexed by their name. Well, for now, I'll do that a little bit later. Let's process an individual field definition, and that looks like it takes a field definition takes some terms, and let's do our trick that we did here. Now we can pull out name. We don't want name in a, we only call it val, and then we don't want name in a list. There we are, so it comes out of the list, and then we can map a function called juxt, where we can have a little accessor here that's going to pull out the name of the name and then the rest of it. Map over there, you'll see what happens. We've got three tuples, 3 pairs. And then if we just do this trick where you can put those pairs into a map, you'll see now we've got field definitions. It's just getting a bit closer to where we are here. We've got the name. Yeah, I think we're almost done, and only we've got to pull out the type. It's because we're not handling type. So let's handle type. Field definition type, and type is going to be process, one of those, and now we've got to process a type underscore, which I think is I got that right. wonder what type underscore means. Oh, a type reference. Oh, perhaps it's called type underscore because type is reserved. Perhaps we need to do this. Yeah, okay. Now we've got to handle named type, and that is name type is it right, type pretty close, type I think in this case of this field definition, going to have to look it up by name anyway. So the field definition needs to be a little bit more cunning. So let's be a little bit discerning here. We know the name so we can sort of say map, and we can say named type there. And we can update our type. There we are. We update in our field definition. Yeah, it would be this sort of thing we would want to update. In this context, we're happy updating with a function that is just going to drill down do that update. There we are. I think that's better. Update. We want to update the type. It was type. Yeah. That's what we wanted. I'm going to probably get rid of that. Okay, looking a bit better now, a bit closer to where we want. Now I only arrived at this kind of, playing around. I hadn't really thought about how we were going to process this ANTLR output before. So multi-methods is one way of doing it, and of course in our case we can be, the downside is that we lose a bit of context with the multi-method, but we could pass in that context here. When we call the multi-method, we could kind of have, if we did ever need to, I think we can get away with it. So we're getting pretty close there. We've got a nice index, field definitions. Each field definition has a kind, a name, and a type, although that kind is not going to be object. That's wrong. In fact, we don't need a kind at all. So yeah, pretty close. And now perhaps we need to go and fix our tests so that we can use a namespace for our keys, but I think we can leave it there. We've still got a couple of not handled ones. Oh yeah, our profile pic has got some arguments. So let's go and do those. Excuse me, just chilly in here. And okay. Of course, if you're watching on the video, you could fast forward. This is not going to be too interesting, but we've got to do it anyway. Definition. So an arguments definition, what does that look like? That has, yeah, we have some terms. I call them terms because I want to include the parenthesis here, but then when we do our filter sequential on those terms, that will get rid of these. Well, these are called terminals, and so we're really, in this case, we're not interested in the terminals. The terminals are really there to provide the parser some sort of cues as to what to kind of some guidance to create the abstract syntax tree. So they're there to shape the tree. So here, this is the information that we're interested in. So having filtered those things out, we want to use our trick of, in fact we'll start with our terms and use our processing trick, and yeah, I don't know why we're removing not handled. We don't want to remove our not handled. In fact, we weren't removing it, wasn't working anyway because we had a bang after our not handled, but that's what, so we're going to process all of these arguments, and arguments definition. So yeah, we want to have it looking a little bit like this last one. Our arguments definition can have a name and a type. Okay, we need an input value definition. Of course we do. What does that look like? What have I done? Done that wrong, haven't I? Arguments definition. Oh no. Input value definition. So, no. Yeah, we process each one of those. Oh, right, and this is where we have the same terms. And we'll do our trick of processing each one of them, but then applying the merge to get them all back into the same thing. Here we are. We've got our merge here. We'll do the same trick with our types. we want to map a function where each argument's definition the input value definition we want to update do this same trick on the input value definition named type name, and then we're going to get that tightened up, and that's great. We have also a description, and that's good. String value, I'm assuming the grammar doesn't distinguish between, I wonder how it does, block, string. It seems to have string. I'm just assuming that it does work. Block string, okay. Okay, good enough. Okay, now we don't need our there we are, our two objects, one for root, one for person, the other one for, we have a scalar type definition to handle, or we can do that. Let's have a look at that.